Hello, I'm Venugopal Reddy Tanamala, pursuing my Masters in Data Analytics at National College of Ireland. My research topic is an approach to detect and understand tumors using cognitive systems. So the problem that we're going to encounter is cancer. The commonly practiced cancer treatments are surgery, chemotherapy, and radiotherapy. Firstly, it is seen that facilities are still unreachable to patients in most remote corners. Secondly, many are unaware about the disease and the knowledge regarding curing and sufficient associations within the medical community. Most widely witnessed drawback is that the treatment would be expensive and many citizens cannot afford. So we're gonna come up with an objective where all patients can understand and find a cure within the community. So we're going to implement a crowdsourcing system, where a crowdsourcing system is an interactive platform where users and organizations communicate and coordinate with an intention to solve a problem, innovate ideas, and work on a common goal with extreme ease and efficiency. Unlike other social groups or networks, people suffering with the diseases can interact publicly with knowledge group, share, request, suggest, and more importantly, learn about the medical care. Some of the examples of crowdsourcing is Amazon Mechanical Turk, Lego or Airbnb, and the image shows the workflow in a crowdsourcing system. So the approach that we used is deep learning. The reason to use deep learning is that machine learning techniques can automate the process, but they are difficult to solve complex problems. So where deep learning can select and extract features, it is a subset of machine learning, and which is very helpful in tumor detection and measures predictive target with efficiency in models. So the model is built using TensorFlow and convolution neural network, and these are the advantages of a CNN model. The reason for using CNN is that it can intake scan images, detect the tumor types, severity, and provide accurate results. A CNN is an artificial neural network that has a type of specialization for being able to pick out and detect patterns. The pattern detection is the unique feature of CNN that is useful for image analysis. The filters are used in these detections, which can detect multiple edges, corners, shapes, textures, or even objects. Next, we're going to talk about the data processing, the data pre-processing. The acquired data set is over 50,000 images, which is high quality, and they represent tumor present in various parts like renal, ovarian, lung, and etc. So these images are reduced into a smaller pixel size, and it should be reduced to like 224 by 224, and further reduction might result in poor image quality. So the images are labeled with respective tumor types, and the labels are extracted using natural language processing. The file is huge, and so it is stored in Amazon web server, and we used the TensorFlow framework. The other modules that it carries are like PyPlot, Pandas, NumPy, etc. So the model that supports deep learning using neural networks needs immense amount of training and computational methods. So the data must be pre-processed, undergoing steps like maintaining a uniform aspect ratio, removing multiple labels, erroneous data, image label correlation, and image input normalization. So next we're going to check about the CNN model, which contains certain filters and layers. And the first one is the convolution layer. Here we will move the feature or even the filter to every possible position of the image. So it carries on steps like lines up the feature and patches of the image, and then the next layer is prelude layer. This layer is mainly used to remove the negative values from the filter images and replace it with zeros. And the next layer we're going to use is pooling layer. So in this layer we shrink the image stack into smaller size, picking up in window size usually, and then will make the window cross across the filtered images. And the final layer is the stack up layer, where the main use of stack up layer is that it will do the classification here, and it takes out the filter and shrinked images and put it into a single list. So this is the detail working here in the CNN model, where you can see an image showing the downsampling of a 3D image into a 2D image. And this is the architecture which we have come across, which contains the crowdsourcing platform with the users making requests initially, and the responses can be acquired from the crowd, doctors, or even the medical communities. This is the actual CNN model which has been collaborated with the crowdsourcing platform, and finally the solution can be delivered to the users. These here are the recommenders which can be used as the future works in our project. The main challenges that we came across is the lack of high quality datasets. Labels are extracted from natural language processing, so which has to be rechecked, and data imbalance may lead to overfitting, and this is a preliminary step for diagnosis, not a standalone process. The image here shows the project plan, which roughly consists of 12 weeks. So that is the project, which will be helpful in tumor detection and could really save upon lives. Thank you.